Hi everyone! So in the prior video we talked about step 3 of metastasis, where we engage in this matrix degradation step. For this video we're going to talk about intravasation. Let me zoom in a bit. Intravasation. And this is the process by which our cancer cell is going to enter the bloodstream. This is my cancer cell. And let me draw out some endothelial cells. Okay. So when our cancer cell is approaching this barrier to attempt to enter the blood vessel, there is kind of one big change that it's aiming to make, which is getting rid of a protein called VE cadherin. And VE cadherin, which I labeled in white here, VE cadherin, it's not the same as E cadherin that we talked about above. This is totally specific to the endothelial cells. Let me label these. These are my endothelial cells. Not epithelial, but endothelial. And it's important for keeping kind of tight junctions and connectivity between the endothelial cells with minimal gaps. And of course, cancer cells are going to want to create large gaps in between these endothelial cells. So there's 3 different things that are going to happen that promote kind of the degradation and inhibition of this VE cadherin protein. So the first is the interaction between the Notch receptor, which is on the cancer cell, with the Notch ligand. This is our ligand on the endothelial cell. This interaction is going to inhibit VE cadherin. We're also going to be releasing MMPs from our cancer cell, and the release of these MMPs not only degrades the matrix, but it also is going to bind to a receptor on the endothelial cell called the PA receptor, which stands for protease activated receptor. And again, binding of this receptor is going to inhibit VE cadherin. And lastly, we are going to be kind of activating this atom 12 molecule. Let me draw this on here. So we'll have a molecule right here that we can call atom 12. And we have increased activity of this atom 12 molecule, which is also going to be inhibiting this VE cadherin. And atom 12 in particular is a protease. I'm not going to go into detail on how atom 12 activity is increased, but just know that it is, and that these are 3 methods by which we are trying to kind of get rid of and inhibit VE cadherin. So once we've gotten rid of VE cadherin, I go to kind of the next logical step. We've gotten rid of the E-cadherin, but we do still have endothelial cells lined up. They're not automatically just going to open up and retract. So the next step in this process is going to be the secretion of a couple different factors by two different cells. So let me draw my cancer cell up here. And then down below, I'll draw, this is my tumor associated macrophage. Also called a TAM, tumor-associated macrophage. And these two cells are going to secrete two different molecules. My cancer cell is going to secrete a molecule called TGF-beta. And my tumor-associated macrophage is going to secrete something called TNF-alpha, which is part of the tumor necrosis factor family. And these are both going to bind to receptors on the cell surface of the endothelial cell, and they're going to promote cell retraction. So once they bind, these cells, if I just kind of makeshift what this would look like, are going to retract, and our cancer cell is able to move through into the bloodstream. So the release of these two factors is what allows for that to happen. So that's our process of intravasation. In the next video, we will talk about transport and capillary